If you've created a new account online recently or signed into an existing one, there's a good chance you've seen that instead of asking you to create a password, the website may have suggested creating a passkey. If you accept, the device will ask you to confirm with like Face ID, a fingerprint, or your device PIN. After that, the site says your passkey has been created. The next time you log in, you just confirm with your face, fingerprint, or PIN, instead of needing to enter a password and deal with dumb two-factor codes. This is obviously much more clean than passwords, but how does this actually work? I mean, does it just turn your fingerprint or whatever into a password? Why does it skip things like two-factor? When I saw passkeys for the first time, my question was what exactly the evolution was that made nearly every website begin using them. Because this happened with every single new upgrade of passwords. Very early on, users chose a password and the computer stored it. When someone logged in, they typed the password and the system compared it to what it had saved. And if the two matched, the access was granted. But of course, because the computer had to store the password somewhere, anyone who could access the system's files could potentially read them. So developers began storing passwords in encrypted form, from which came hashes, which are mathematical functions that scramble passwords into outputs that couldn't be realistically reversed to reveal the original password. And this became the foundation of modern password storage. But there was still the problem that if two people used the same password, they would still produce the same hash, making large-scale attacks easier. And to address this, the algorithms added something called salting, which added a random value to each password before hashing, ensuring that even identical passwords would produce different stored results. And as the internet grew, passwords became the standard method of authentication across the entire web. I mean, the concept is super obvious, right? You need something that only that user can input as a way to validate their identity, and would obviously be a password. But this means authentication still depended on a secret the user had to remember and type. It's just that passwords have been such a common thing even before the internet that these quirks of passwords were a given and not something that needed fixing. Which is why we would still deal with two-factor authentication, because all it does is adds a second step after the password, so that if someone stole your password, which clearly was a big enough issue to warrant dealing with two-factor codes, they would still need access to your authenticator app, your phone, or in some cases your physical security key. I know I'm complaining a little bit, but the system ensured that you basically could never be hacked unless you lacked common sense and opened shady links or trusted fake websites. And today when you create a password for an account, it gets hashed and then stored in the site's databases, and for most people, your device's password manager. You then need to take the second step of adding your phone number and verifying it or connecting an authenticator app, something that way too many websites don't even tell you to do, like you have to go into their settings yourself to set that up. So it is a secure system that just assumes every user has enough knowledge and responsibility of their passwords and account security. You're expected to create strong passwords that are long and random every single time. You're told not to reuse them across multiple different websites. Basically, you're expected to remember dozens or even hundreds of unique credentials. And in reality, most people just don't do that. Even though password managers exist, you may not always have access to one. So many reuse the same password across multiple sites to not have to deal with all of that. And of course, there is still the problem of data breaches and phishing. Nothing really stopping your credentials from being leaked because a big website just happened to be stupid with how they store them, and also nothing stopping you from being misled into a fake login page where you willingly enter your credentials. Two-factor authentication helps reduce the damage from these, but not only do some people again not have it set up as we talked about before, but there are actually techniques to intercept authentication codes by basically like rerouting your SMS to their device, which obviously won't be done on a random person, but if someone has your phone number and password, which they very well could have from some random data breach that you don't even know about, then it's always a possibility. So it was becoming clear that passwords have a fundamental weakness that prevents us from making them properly secure. Passwords are secrets that both the user and the server must know, and if that secret leaks anywhere along the chain or is forgotten, the entire system breaks. So then, instead of sharing a secret between the user and the server, what if authentication relied on something that never had to leave the user's device? That idea eventually led to the development of passkeys. The modern passkey system grew out of standards developed by the FIDO Alliance, an industry formed in 2012 with the goal of reducing the world's reliance on passwords. Companies like Google, Apple, Microsoft, and many others collaborated on a system that would allow secure authentication without requiring users to remember anything. Public key cryptography has existed since the 1970s and is widely used across the internet for encryption. Instead of relying on a single shared secret, it uses a pair of mathematically linked keys. One key is public and can be shared freely. The other key is private and must remain a secret. What makes the system powerful is that the data encrypted with one key can only be decrypted with the other. But more importantly for authentication, a message signed with the private key can be verified using the public key. Passkeys apply this idea to logging into accounts. So when you create a passkey on a website, your device generates a brand new pair of cryptographic keys. The private key stays on your device and never leaves it, and you're able to make multiple of them for your iPhone via Face ID, or your PC via PIN code, or an actual physical YubiKey. And the public key is sent to the website and is stored on its servers. And so from that moment on, the website doesn't need a password from you anymore. Instead, when you attempt to log on, the website sends a cryptographic challenge to your device. Your device signs that challenge using its private key, and the website verifies the response using its public key that it already has. If the signature is valid, the website knows that the device holding the private key is present and you are authenticated. The important difference here from the passwords we're used to is that the private key never leaves your device. It isn't transmitted across the internet and isn't stored in the website's database. Even if the website suffers a breach, attackers only obtain public keys, which cannot be used to impersonate users and still require a private key in order to work. And at that point, the only way to obtain one is to literally get the physical device or security key of the user you're trying to hack. This is honestly such a beautiful and smart design that eliminates so many foundational problems of passwords that we've just kind of dealt with for a while. Now there's no shared secret to steal from a server, there's nothing for a user to accidentally type into a phishing website, and there's no password that needs to be remembered or reused or reset. When you approve a Passkey login with Face ID, a fingerprint, or a device PIN, you're not sending that biometric data to the website. Those methods simply unlock the private key stored securely inside your device's hardware. And modern phones and computers include secure hardware components designed specifically to protect these private cryptographic keys. So from the top of my head, I know that Apple devices use the secure enclave, Android devices use hardware-backed key stores, and many laptops rely on TPM security modules. These systems ensure that private keys cannot be extracted even by malicious software, just in case you felt that they weren't secure enough. It's just a very efficient process, man. I have an iPhone and MacBook, and I found that if you create a passkey on your phone, it can sync through encrypted services like iCloud Keychain or maybe Google Password Manager to your other devices. So this allows me to log in from the phone or MacBook without manually transferring anything. I was a bit confused about this with the whole thing of passkeys being, on device, but turns out a copy does get stored on iCloud and such. It's just done with so much encryption that it only works for trusted devices, and Apple or outsiders cannot decode the key at all. Only your devices can, so I guess that still counts. And if you try to sign in on a device that doesn't have your passkey or isn't connected to one of those cloud services, you can still authenticate using a nearby phone via scanning a QR code on the trusted device, for which Bluetooth is actually used to ensure it's actually in range and you're not being remotely scammed by someone, which is pretty funny, and then your phone allows the sign. And you may be asking now, what's the point of passwords and two-factor then? And the answer is that there really aren't any. I mean, they'll still exist to be compatible, but a passkey alone already provides the same level of protection, if not more, that previously required both a password and 2FA, and it's all done in one super easy step. So now instead of dealing with multiple passwords and two-factor, you can now have one passkey for every site that you can easily manage. For fun, I even bought a YubiKey and added that to my accounts, so that if I somehow lose access to all of my devices and password managers, I'll still have a secure way to access all of my important accounts, something you could also play around with. And thank you for watching.